Hey everybody, let's keep going with problem number 3. We want to graph y equals square root of x minus 6. And if you remember, the square root graph is that half a parabola turns sideways. We haven't looked at that one in a while. We can do that, but if we subtract 6 from it, we're going to slide the whole thing down 6. So maybe it's down here at 0, -6, and then it's that half a parabola, so it's going to go something like that. Here's my x-axis, and it goes a little bit above that. To get the inverse, we do the same thing we've always done. We switch x and y, so it's going to be x equals square root of y minus 6, and we use our solving skills. Add 6 to both sides, and I get x plus 6 equals square root of y. And to get rid of the square root, we square both sides. So it's x plus 6 squared equals y. I'm going to turn it around a little bit so we can see it the other way. Y equals x plus 6 squared. This is vertex form of a parabola, right? And our vertex is going to be -6, 0, 0 because there's nothing added on. So if I graph that, it would be over here somewhere. I don't want to graph the whole parabola though, because remember, I want the graphs to be symmetric across the line y equals x. So I really only want this half of the parabola. And again, there's our y-axis coming up there. So now you can see they're symmetric across y equals x. So what happens is when we get to this parabola thing, we have to say we only want the x values bigger than or equal to -6, because we don't want to go on the other side of this, or we're not going to get that symmetry. So the last one here, k of x equals 2x minus 8. This is the exponential function that we've been working at for a while. So y equals 2 to the x minus 8. Remember, that gives us a graph. It's a growth because it's 2 to the x. And it's shifted down 8. So down here somewhere, we have an asymptote at y equals -8. And we just kind of draw in the graph. It's going to be growth, something like that. Right? And this point here we know is 0, -7, because we plug in 0 for x. 2 to the 0 is 1, minus 8 is -7. The inverse, again, we're just going to switch x and y. So we've got x equals 2 to the y minus 8. And we use our solving skills. Add 8 to both sides. I've got x plus 8 equals 2 to the y. And here's the new bit. How do we undo exponentiation, raising to a power? And this is where logarithms come in. Remember, if we have base to some exponent equals a power, and we do, this is our base, 2 is the base, y is the exponent, and this whole thing over here, that's the power. We can rewrite that as the exponent equals log with that base of that power. So I'm going to rewrite this as y equals log base 2 of x plus 8. And if we want to know what the graph of that looks like, we want to deal with the graph that we've already got. Remember, we're going to switch x and y. So the asymptote on the original was y equals -8. The asymptote on the new one is x equals -8. And the point on the original was 0, -7. So the point on the new one is -7, 0 on the inverse. And we just kind of sketch in the graph. I don't know what happened there. There it is. And again, it's still symmetric across the line, y equals x. And last bit here, the domain, just to make sure we're clear on this, the domain on the original is all real numbers. The range on the original, we don't go below the asymptote, so it's y is bigger than -8. On the new one, the domain is x is bigger than -8 because we don't go to the left of that asymptote, and the range is going to be all real numbers. And last bit on this, if I've got a moment here, as x goes to infinity on the original, y goes to infinity. As x goes to -infinity, y goes to -8. On this one, as x goes to infinity, y goes to infinity. As x goes to, we say, -8 from the right, y goes to negative infinity. As x goes to negative infinity, y doesn't exist because there's no graph over here on the left for the orange graph. Thank you. I'll see you next time.